SAM is a statistical method that allows us to find the significant features that best describe a set of observations as organized by a response variable. And in terms of OMIQ, and in terms of normal workflows being executed on OMIQ, what this means is we can take a set of files, and these files have to be organized by some sort of metadata. And the metadata can be categorical or they can be continuous, because SAM is fairly flexible in terms of the types of statistical analysis it can do. So for example, given this set of 14 files that I've selected, which are individual patients at day 30 and day 90 post bone marrow transplantation, the first thing that I'm going to decide in terms of my SAM analysis is which metadata variable that I've previously set in this data set am I going to use to try to organize these files. And so as with other examples using this data set, what I'll do is choose the day variable because I'm interested in finding differences between day 30 and day 90. But if I had some sort of continuous variable that I wanted to regress to, I could use that as well. And I also have this variable, patient, which is a pairing variable. I'll talk about that in a second. Now that I've selected my metadata variable, what I want to ask is what type of analysis do I want to do? And this is the type of statistical analysis and that I'm trying to get an answer for among these files. A very common statistical question to ask is simply two-class unpaired, meaning I have two classes that describe these files. And as I said before, in the day class, we have day 30 and day 90. But what I can also do is multi-class. So if I had three classes, maybe if I had day 120, quantitative would be if I wanted to do my continuous variable. And I can also do a two-class paired, which in this case opens up another pairing variable. And here's where I'll choose my patient. So I have day as the general variable and patient as my pairing variable. I'll stick to two-class unpaired for now. And I have also the additional option of what type of test statistic I want to use for each feature that is being analyzed by the algorithm. And this is either standard or Wilcoxon, standard being the t-based statistic. I then have to choose which filters I want to be looking at for this analysis. And as I've done before in this example data set, we're going to choose the metaclusters that we found in FlowSum. There's 20 of them. Next, I'll choose what measure I'm going to be analyzing to differentiate these files. And abundance is the one by default. It's very common in these type of workflows. But we can also choose medians. And we can choose these at the same time or at different times. Usually it would be suggested to choose them differently, but SAM can accommodate both. If you choose medians, what will open up is this panel to be able to choose whichever features you want from within the raw data. And so if we were looking at, for example, cellular populations, I'm trying to understand maybe there's correlations in marker expression on individual cell populations between groups, we would choose the markers that we're interested in looking for those differences on. In this case, for the first example, I'm just going to stick with abundances. So I'll turn that off. Then I want to set the number of permutations. This is a way to increase the confidence of certain estimated statistical parameters within SAM. It's a fairly detailed thing here. The advice from the people who created SAM is something like 100 or 200 is fine just for initial results. But if you want really precise results, it's good to put it up to about 1,000. FDR cutoff is a way of making the number of results, or really the results that are reported, more stringent or more loose. So making this number smaller will return stronger and fewer results. Making it larger will return more results. And then a C is for reproducibility. Once these parameters are set, we can go ahead and run SAM.